In this video, we will investigate sine and cosine from a graphical perspective. So pictured here are the graphs of sine and cosine. And recall from one of the basic properties of sine and cosine, sine of t plus 2 pi is equal to sine of t, and cosine of t plus 2 pi is equal to cosine t. And what this is telling us is if we have an idea of what the graphs of cosine and sine look like on the interval from 0 to 2 pi, then you can extend that pattern to see what they look like indefinitely. Notice that both of their graphs are nice smooth curves that oscillate between 1 and minus 1. A few nice properties that you can see is what sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is minus 1, sine of 2 pi is 0. Similarly, cosine of pi over 2, cosine 3 pi over 2 are 0. Cosine of 0 and cosine of 2 pi are both 1. And cosine of pi is minus 1. As the sine of t plus 2 pi is sine t and cosine t plus 2 pi is cosine t, we say from a mathematical perspective that cosine and sine are periodic functions with period 2 pi. And to say that the function is period 2 pi is that it repeats itself every 2 pi units. So if you have cosine or sine evaluated at t plus 2 pi, or t plus any multiple of pi, any multiple of 2 pi, you will get the same exact value. And additionally, the period of sine of at, where we throw an extra number in front of the t, is going to be 2 pi over a, which is an extremely useful fact. Additionally, the amplitude of sine and cosine is defined to be half the distance between the highest and lowest points on their graph. Or, stated differently, if you look at kind of the maximum and minimum values, the amplitude would be the distance that maximum value is away from the x-axis. So the sine and cosine functions have amplitude 1. In general, if you have f of t equals a sine t, its amplitude will be the number a. So let's look at a basic example. Let's sketch the graph of f of x equals sine of 3x. Now, the key observation to make here is because of the 3, the period of f of x will be 2 pi over 3. So in order to graph this, what we need to do is take the normal sine graph, which has a period of 2 pi, and condense it down so its period is 2 pi over 3. So what normally would happen at 2 pi is now happening at 2 pi over 3. So at sine of 2 pi over 3 and then pi over 3, our function is going to be 0. Because note, if you have sine of 3 times 2 pi over 3, this is sine of 2 pi, which is 0. Sine of 3 times pi over 3 is sine of pi, which is 0. So if we think about what the sine curve looks like, we know that it starts off at 0, it goes up to 1, and then we can just continue this pattern on. And if you want to know, for example, where is this maximum we're seeing between 0 and pi over 3, well, this would be pi over 6. So sine of 3 times pi over 6 is equal to the sine of pi over 2, which is equal to 1. And so this would be the graph of sine of 3x. Take the graph of sine x, compress it down so its period is 2 pi over 3. Another question that we could ask is to determine the period, amplitude, and shift of some given function involving cosines and sines. So looking at the first example, we can note because of the 3x that the period will be 2 pi over 3. Because of the 1/3 in front of the cosine, we can say that the amplitude will be 1/3, and the shift, because it's 2 plus out front, would be a vertical or upward shift of 2 units. So it's 2 units up. Let's look at another similar example, and we'll see where we have to be maybe just a touch careful. So in terms of the function given here, the easiest thing to pick off is the amplitude. Because of the 3 out front, the amplitude is 3. But in order to see the period and the shift, we do need to rewrite a touch. We can write this as sine of the quantity 2 times x plus pi over 2. And looking at the x plus pi over 2 portion, well, x plus pi over 2 is going to shift us pi over 2 units to the left. So pi over 2 units left. And then lastly, the 2 that we've pulled out is going to determine the period. So the period would be 2 pi over 2, which is simply pi. So we see where we have to be careful is determining what that shift is by factoring out the number 2 in front of the x plus pi over 2.